Hello everyone, this is William from Visual Components, and this video series is about point clouds and topology. So there'll be three videos. For the first part, I'm going to show you how to import or load a point cloud file into the 3D software, as well as create and use point clouds. In the second video, I'm going to show you how to create point clouds with different data types using VC triangle sets and a different couple of methods. And the last video, part 3, I'm going to show you how to create point clouds with topology. So to get started, what is a point cloud? A point cloud is a set of points or positions in a coordinate system that can be used for both visualization and practical purposes. For example, you can generate points on objects for quick selection actions by robots if you wanted to. And you can also reconstruct surfaces and environments and perform quality testing of parts you have based on the measurement data. Now, if you are a 3D Automate user, this video series is primarily for you. However, if you do have 3D Simulate with a special license, you can use Topology. Alright, let's go and get started. So we'll start with the basics. I'll show you how to load a point cloud file as well as import one. Now, it's just like any other normal file. You can drag and drop it in the 3D world like you would an item from the ECAT. What you can also do is go up to File menu here, go to Import, and the dialog opens for me to open a file. And notice here I'm using an XYZ file type. Now there are several file types you can use to import a point cloud. This is just one of them. So I'll select it here and open. Notice now the component is in the 3D world. I'll fill to get a better view. And you notice the file is pretty small, but you can see there are all those points that was created for the component. And so when I zoom out, it looks a bit more clear, but when I zoom in, you see more of the detail and how far the points are spaced apart. So let's go and talk about the structure of when you import a point cloud file. So you notice just like any other normal component, you have a root node, a root feature, you have a mount frame that's created, and you have a geometry container or a geometry feature. Now point clouds are contained in a special type of geometry set called point set, and I'll show you how to access it now. So I'll go to the behavior tab here. And I'll go down here to create a Python script behavior. Now, mostly when you're working with point clouds, you want to create them or, create points from geometry. You have to work in Python script, okay? So first get a handle for the component. So comp equals get component. And this allows me to use all those methods and properties in VC component. I'll now get the geometry feature. So I'll say gf equals comp.findFeature. And I'll just use its name of geometry. And now what you could do is get direct access to a geometry container by just using the geometry property of a geometry feature. However, what you can also do to make it clearer is just write gc for geometry container equals gf.geometry. So now, if I go ahead and print the geometry container's geometry sets. Let's see what happens. Notice I have a VC point set object, and that's what point clouds are contained in, that special type of geometry set. Okay, I'm now going to show you how you can create your own container to then start creating point clouds. So I'll go ahead and close this out, and I'll click New here to open a new layout. Let's click Fill to get a better view. Alright, so we're probably going to be working the Create tab, and you do have to get your hands dirty with Python script. Woohoo! Alright, so go to the Geometry tab here, and I'll create a simple dummy component and with one geometry feature. Alright, close this out. I can now go to the Behavior tab, and I'll create a Python script behavior. Alright, then we can now do some coding. So once again, I'm going to go and get the handle for the component object. So get component. And now I'll go ahead and get the handle for the geometry feature. So comp.findFeature, and I'll reference the feature's name, which is geometry by default. Alright. Now for the geometry container, gc equals gf.geometry. And now I can create a new geometry set in this container of the VC point set type. So what I'll do, just to make things simple, is I'll say ps for point set equals the geometry container, and I'm going to use the method create geometry set here. So create camel case geometry set, and this takes a constant value. So I'll say vc point set to define its type. All right, and I'll go and give this a name. So I'll say ps dot name equals string of point cloud, like so. So now to make sure I have a handle for the point set, I'll go ahead and print PS. And let's see if it all works out. Yep, so I now have a new point set object and I can start creating points. Alright, I'm now going to show you how you can create points in the VC point set object. So points can be created by using the add point method with the point set object. So the syntax for the method allows you to give XY coordinates for the point's position, as well as RGB color space values for the point's color. So you can define the position of a point as well as define its color. So I'll go and access my code here. Don't need to print it out anymore. And what I'll do is I'll say a for loop, so for x in range 500. So I'm using x here to reference the x-axis position. And then what I'm going to do is create another for loop. So for y in range 500, colon. So notice I'm getting a value in x, and then I'm looping through the y. So each time it's going to do the x value and then do all these y values. So I'll get a nice xy plane here in the 3D world. So now I'll say ps for the point set, and I'll use that method add point. And I'm going to keep it simple by saying x, y, and I'm just going to keep the z value, or the height of the point, static, so I'll use value of 100 here. And notice I don't have to pass any RGB values right now. I can just use x, y, z values for the point's position. So once I get done with my loops, I'm going to go ahead and update the point set object. And I'm going to go ahead and update the application as well to render it in the 3D world. So what you want to do is say app for application equals get application. And this method is in VC script. Notice I'm importing it here. And then I'll do app.render. Alright, so let's go and see how this works out. So I'll compile the code, let it do its thing. And now what I'm going to do is going to click the geometry sets filter here to update everything. Notice I now have the points in the 3D world here. So let's go and zoom in a bit on them. You can notice there are my points. Now by default the color of the points is white. And let's go and zoom in a bit. So you can see they're all spaced at various distances. I'm now going to show you how to remove points that you've created in the 3D world. Now points can be removed by using the clear points method with the point set object. Note that when you use this method you're removing all points in the point set object you're working with. So what I'm going to do right now is I'm going to get a handle for the point set that I named point cloud, because I don't want to recreate another point set object. So what I'll do is I'll go ahead and loop through the geometry sets that are in the container I'm working with. So I'll say for geometry sets in GC geometry container dot geometry sets, and this property returns a list of the geometry sets in it. Go ahead and loop through. So if gs.name is equal to, let's go ahead and get this point cloud name here. So if the name is equal to point cloud, colon, go ahead and get a handle for it as ps equals the geometry set it finds. Alright, so what I can do now is I can say point set dot clear points. So with this method it's going to erase all the points in that point set object. And I'll go ahead and comment out this loop because I don't want to recreate the points just now. And I'll go ahead and compile. Alright, and notice none of the points have been removed from the 3D world. Now if you wanted to recreate points in the same point set object, I do recommend using the clear points method before you do all those points again, because they might overlap. So if I recreate it again, notice there are all the points again. I'm now going to show you how to change the color of points you create in the 3D world. Now a point's color is defined in RGB color space. So red, green, and blue values are fractional and range from 0 to 1 to indicate how much of each color you're using. For example, the default color of added points in the 3D software is white, so the RGB values are at their maximum of 1.0. Now in an 8-bit channel, the color values will be from 0 to 255. So if you go online and you get like an RGB color and it's like 240, 13, 180, what you can do is simply divide those numbers by 255 and then use them in your when you assign a color to a point. So actually let me show you an example. So here's kind of how it all works in the Cartesian coordinates. So notice that when you pass a RGB value of 0, 0, 0, it's all black. When it's 1, 1, 1, it's the maximum value, so it's white. All right, so let's go and do some examples now. So what I'll do is I'll go ahead and uncomment the loop like I've already done. And now I'm going to add some color when I add these points again. So notice I'm clearing them and then I'm recreating them. So with the position of the point, I can now choose the color, so I'll make them black now. So 0, 0, and 0. So let's compile the code. So it's recreating the same points, but now they're going to be black, as you can see in the 3D world. So now if I want the points to be red, I can simply change the value I'm passing to be a full value of red with green and blue at 0 value. So there's red. And now to get blue, let's make the blue value 1 and all the other values 0. Alright, and there's the blue. Now you can also use a color list like I mentioned before if you want to get fancy. So what I'm going to go and do now is take you to a website called cooler.adobe.com, and this allows you to quickly, set up your color palettes and get access to RGB color values. Alright, so here's the website. It's cooler.adobe.com, and notice you have a color wheel here and you can quickly select different colors by moving them around. So you notice you have different modes here as well. So what I'm going to do is I'm going to get the RG value of one of these colors. So I'll go down here to get this color. Notice I have the RG value here, and I can also get it in hue and saturation if I want it as well. So let's see, it's 255, so a full value of 1. For the green it's 13, and for the blue it's 255. So 255, 13, and the other one's 255. Alright, so I'll go ahead and minimize this, and I'll go back to my code. So what I'll do now is I'll go and create a variable called RGB, and this will be a list. So I have my square brackets, and for that red it was 255, for the blue it was 13, I'm sorry, for the green it was 13, and for the blue it was 255. Alright, so now I can go ahead and get those values. So where I'm adding the points, I'll say RGB is going to be the first value, the index value of 0, and I'm going to divide it by 255. So now I'll do RGB again, square brackets of 1 divided by 255. So I'm referencing the 8-bit color channel as well, just remember that. So RGB, now the last value of 2 divided by 255. So it's creating the points, and it's getting a color value that I just got from a different website, and I'm dividing these by 255 and then getting the color value for the point. So now let me go and make this a little bit bigger. Alright, so I'll compile. And notice, hey, there's the color I just picked. You can also use vectors for the Cartesian coordinate system to create colors. So I'll go up to the top of my code, and I'm going to be referencing a vector value between 0 and 1. So I'm going to import VC vector, like so. Now I can go ahead and change RGB from a list to be a new vector, so VC vector dot new constructor. And let's go ahead and make the points blue. So remember, it's going to be 0, 0, and then blue has a value of 1. So just to show you again what I'm talking about, it's this. So for the X, Y, and Z, it's choosing the color of blue. Alright, so go ahead and have that now. So now I can assign it here when I add the points. So RGB dot X, remember it's a vector, so referencing the X position of it. RGB dot or period Y, comma, and now for the Z value, RGB dot Z. Alright, so notice that I imported VC vector, I created a new vector, and now that vector's position is going to change the color of the points. So now I'll compile the code, and notice now the points are blue. Alright, now if you do want to create gradients and mess around with the colors of the points, you can do that. I'll go ahead and comment the RGB out. I don't need it anymore. And what I'll do now, during my loop, I'll create a variable called R equals float. And notice I'm using the standard Python command of float. And so because what's happening is that for the x value, it's going to go from up to 500, and these are integer values. So what I want to do is convert that integer value to a float. Now you can use the float method with the x, and I'll divide it now by 255. And now I'll do the same for the green value. And instead of the float method, you actually could just take the value and times it by 1.0 to make it a float. So now I'm going to divide by 255 as well. Alright, so what I can do is go ahead and assign the R value for the color and the green value. So now I need to actually change the X and the Y. So for the Z value, I'll go ahead and keep this just normal as 0. Actually, no, let's keep it as 1. Alright, so notice I'm getting a value for red divided by 255 and a value for green divided by 255. So now if I compile the code, notice I now have this interesting looking gradient. If I mess around with the Z value a bit, make it 0, you notice I now have a different gradient. And if I make it 0.5, notice it looks like that. I'm now going to show you how to create an RGB color space cube in the 3D software, and this will allow you to get a better idea and understanding of where these color values are coming from. Now this is optional, and if you do choose to follow me and render the cube, it will take some time to load in the 3D world. So what I'll do is go to my code here, and now I'm going to create a loop for the Z value. So for Z in range 255, remember I'm using the 8-bit color channel. I'll now go ahead and indent this line of code I already have, like so. Now get a value for the blue. So blue is going to equal, I'll just use the float method again for Z, divided by 255. So now, over here when I add the point, I need to make sure I'm adding that Z value. And for the blue, I need to make sure I'm adding that blue value. So I'm going to go ahead and compile the code now, and I'm going to fast forward to when it's rendered in the 3D world. Alright everyone, the color cube is now being rendered, so I'll go and show you what's up. So notice when I was creating those colors, I was picking a position within this cube. So notice we have the dark value here for 0, 0, 0, and the white value here up the top for a value of 1, 1, 1. I'm now going to show you how to increase the size of points as well as scale the rendering of points in the 3D world. So I'll go to my code here, and I'll clean it up just a bit, so I won't use these RGB values anymore. I'll just use the default white color for the points. So I'll clean it up like so. And I don't need to render the Z value anymore, I'll just keep it on the XY plane. And I'll make the Z value a default height of 100 so we can see it off the floor. So I'll change from 255 to be 100, as well as 100 for for Y as well. So now if I go and render this out, notice I just have those points here in the 3D world. Whoops, let's go ahead and get a better view of those points. So now if I want to change the size of the points, I can either before or after the clear points method, I can use the pointSet object and its property called point size. The default size of points is 1.0 millimeters, so I'll go ahead and pass a new real value of 5.0. So if I now render this out, notice the points do kind of appear bigger, but they're still kind of spaced together. So what I can do instead is create a scale factor. So I'll use the pointSet object, and I'll use that property of scale, which has a default value of 1. However, I'll change the scale to be 10.0 real value. And now for the Z value, I don't want it to increase that much, so I'm actually going to define it by 10, which is the scale value I'm using. So now, if I go and compile the code, notice I now have scaled the rendering of the points in the 3D world, their position I mean. You can notice the point size of each point is very different now. It's quite larger, you can see it better. I'm now going to show you how you can select points in the 3D world. So what I'll do is I'll go up to the Tools menu item here, and I'll select Measure. So I'm just simply going to do a simple measure of the points. So you can notice when I have the points filter here active, I can go ahead and select any of those points I created in my point cloud. So if I actually select this point down here and this other point, you can notice that they are spaced at 10 millimeters apart. So my scaling factor did work indeed. So now what I can do is go ahead and add a robot to the 3D world and pick those points to create RSL motion statements. So what I'll do is I'll go ahead and hit the escape T to exit out of the measure. I'll go and close my Python script. I'll go to the ECAT, and for the Webby Catalog 2014 collection, I'll do a search for generic. And I'll add the generic articulated robot to the 3D world origin. So I'll double F click. Alright, let's do fill. You can notice there's the robot. And now what I can do is go ahead and move my point cloud. So I'll go to the components drop-down menu here in the dynamic toolbar and select that dummy component of name. And I'll use the translate command. So now when I move the component, notice I'm also moving those points as well. So I'll go and move it to an X value of 500, a Y value of minus 500, and a Z value of 500, just so the robot can reach everything. Alright, so now it looks like that. Now what I'm going to do is go ahead and space out the points just a little bit better so the robot can pick them. So what I'll do now is I'll go back to the Create tab, and notice I'm still working with the dummy component. I'll access the Python script, and from here I'll go ahead and change the scale factor for the points to be 20, and I'll also change the X and Y range to be 50. And make sure I divide the Z value by 20 as well, so it keeps it at the same level. So now, I'll move this out and I compile the code. Notice the points did change a bit. Alright, so let's now close this out and go to the Teach tab to work with the robot's program. So I'll select it in the 3D world. I'll go to Translate Tool. And now, if I want to pick one of these points, I can use the Snap on Position command here. And notice I can pick those points, so I'll go ahead and pick this point here, and notice the robot moves to that position. So now let me go and rotate the tool just a bit, so I'll rotate it 180 degrees, and I'll create a point-to-point motion statement there. Alright, now what I can do is use another Translate Tool command. So I'll use Translate Tool, I'll use Translate Along Vector. So now go and select the point I was working with. Let me actually turn these filters off. So I'm just going to select that point right there. And I'll select this endpoint here. So notice the robot moves to that position, and I can now create a linear motion statement. I'm now going to show you how to use a different snap command. So notice I have the translate tool for the robot. I'll go to the dynamic toolbar and select snap position to position defined by 3 points. So I'll go and snap this first point I selected over here. I'll snap the point the robot is at right now. And I'll go ahead and snap the point all the way at the end over here. So notice I'm now in the center of the point cloud I created. So I'll go and create a linear motion there. And I'll go and turn the trace on. So in the Teach tab, I'll go and create a set binary output statement. And once the robot reaches position 1, it'll then trace all the way to position 2 and position 3. So let me go and use a signal value of 17 to turn the trace on and use a red color. So now let's go and run the simulation. So I'll reset and run. Alright, notice the robot moved to those positions and traced. It was a little fast, so I'll go and create a cycle time for position 2. So I'll synchronize the joints to be a cycle time of 5 seconds. So now if I reset, run the simulation again, notice the robot moves in that straight line to each point. Alright, this concludes the first part of the video series. If you have any more questions, please feel free to visit our community at community.visualcomponents.net, and look forward for video 2, which will cover more about creating points using different data types in VC Triangle Set.